The moon, our celestial companion, has captivated humanity for millennia. Its serene glow and ever-changing phases have inspired countless stories and poems. But beyond its familiar face lie secrets, hidden features that have puzzled scientists for decades. Among these mysteries are the lunar swirls, strange bright and dark markings that snake across the lunar surface. These enigmatic patterns, visible through even a modest telescope, have long defied explanation, prompting a flurry of scientific inquiry. Unlike craters or mountains sculpted by impacts or volcanic activity, the lunar swirls seem to defy conventional geological explanations. They are not randomly scattered, but often form intricate loops and whirls, reminiscent of brushstrokes on a cosmic canvas. These peculiar shapes have fueled speculation, ranging from theories involving remnant magnetism to the influence of cometary tails. Recent scientific breakthroughs have shed new light on these lunar enigmas, hinting at a fascinating possibility. The swirls might be visual manifestations of what lies beneath the moon's surface. Scientists now believe that the key to understanding these strange markings lies not on the surface but deep within the moon's interior. Using data from lunar orbiters, researchers have discovered something remarkable. Magnetic anomalies, regions of localized magnetism, often coincide with the location of the swirls. These magnetic anomalies are thought to be remnants of the moon's ancient magnetic field, a force field that once enveloped our celestial neighbor. While the moon's global magnetic field vanished long ago, these localized pockets of magnetism persist, like ghosts of a bygone era. These magnetic anomalies, however, are not just intriguing relics, they appear to play a crucial role in shaping the lunar swirls. The discovery of magnetic anomalies coinciding with lunar swirls has led to a compelling theory. These invisible magnetic fields act as shields, protecting the lunar surface from the relentless bombardment of the solar wind. The solar wind, a stream of charged particles constantly emanating from the sun, is known to darken the lunar surface over time. However, the magnetic anomalies associated with the swirls deflect the solar wind, creating sheltered regions where the surface remains brighter. Imagine these magnetic anomalies as invisible umbrellas, shielding the lunar surface from a cosmic drizzle. Over billions of years, this constant bombardment of the solar wind has darkened the exposed lunar surface. But the areas protected by the magnetic umbrellas remain relatively pristine, creating the striking contrast that defines the lunar swirls. This interplay between the solar wind and the moon's localized magnetic fields offers a compelling explanation for the formation of lunar swirls. The solar wind, carrying charged particles, interacts with the magnetic fields, creating a complex dance of electromagnetic forces. This interaction influences the way the solar wind weathers the lunar surface, leading to the distinctive patterns we observe. Think of it like this. Imagine a windy day at the beach. The wind, like the solar wind, carries sand, which can erode and shape the landscape. Now, imagine placing a series of magnets of varying strengths beneath the sand. The magnets, representing the lunar magnetic anomalies, would deflect the sand-carrying wind, creating unique patterns in the sand dunes. Similarly, the moon's magnetic anomalies channel and deflect the solar wind, leading to the formation of the intricate swirls. Section 5. Simulating the swirls, a scientific breakthrough. To test this theory, scientists have gone beyond observations and turned to computer simulations. By modeling the interaction between the solar wind, the moon's magnetic field, and the lunar surface, researchers have been able to recreate the formation of lunar swirls with remarkable accuracy. These simulations provide further evidence that magnetic anomalies are indeed the driving force behind these enigmatic features. Imagine a virtual wind tunnel, where scientists can control the flow of the solar wind and the strength and orientation of magnetic fields. By replicating the conditions found on the moon, these simulations allow researchers to watch as virtual lunar swirls emerge over time, mimicking the processes that have unfolded over billions of years. Section 6. Echoes of an ancient lunar dynamo. The discovery of magnetic anomalies associated with lunar swirls offers more than just an explanation for these curious features. It provides a tantalizing glimpse into the moon's distant past. The presence of these magnetic pockets suggests that the moon once possessed a global magnetic field, generated by a molten churning core, much like Earth's magnetic field today. This ancient lunar dynamo, however, eventually shut down as the moon's interior cooled and solidified. The magnetic anomalies we observe today are thought to be the last vestiges of this once powerful magnetic field, frozen in time like insects trapped in amber. Section 7. Unveiling the Moon's Magnetic Past. Studying these magnetic anomalies could provide valuable insights into the Moon's thermal evolution and its early history. By understanding how and when the Moon's magnetic field formed and dissipated, scientists can piece together a more complete picture of our celestial companion's journey through time. Imagine these magnetic anomalies as time capsules, each holding clues about the Moon's ancient magnetic field. By carefully analyzing the strength, orientation, and distribution of these magnetic pockets, scientists can reconstruct a map of the Moon's past magnetic field. This, in turn, can reveal valuable information about the Moon's thermal history and the processes that shaped its evolution. Section 8. Future exploration mysteries await. The discovery of magnetic anomalies associated with lunar swirls has opened up new avenues for lunar exploration. Future missions to the Moon could target these magnetic regions, deploying instruments to study them in detail and unravel the mysteries they hold. These missions could provide unprecedented insights into the Moon's history, its interaction with the solar wind, and the fundamental processes that govern planetary magnetic fields. Imagine a new era of lunar exploration, where rovers equipped with sensitive magnetometers roam the lunar surface, mapping the magnetic anomalies in high resolution. Astronauts venturing out from their lunar habitat could collect samples from within and around the swirls, providing valuable data to unlock the secrets held within these enigmatic features. The Moon, once thought to be a desolate and unchanging world, is now a treasure trove of scientific mysteries waiting to be unraveled.